This is how a reactive application, which calls two services, one of them is fast and another one slow, looks like. You can clearly see that the application is non-blocking. The faster data, which arrives first, is delivered to the front end, and the slower data comes later. Let's visualize a non-reactive application first. Here the user makes a request to our app, which in turn calls the fast service first, and then the slow service. It waits till both the services have returned. Only after that it returns the final data to the user. This is a blocking architecture. In contrast, reactive architecture works in a non-blocking way. The user calls our app. Our app calls the fast service and returns the partial data to the user. Our app also calls the slow service, and when the slow data arrives, it is also passed on to the user. This is a non-blocking architecture. Welcome to Clean Code Camp. We will talk about Spring Reactive Programming in this video. Stick till the end and I'll prove to you that reactive architecture is non-blocking and hence perfect for certain types of applications like dashboards, chat applications, and streaming services. In this video, we will cover the following topics. What is reactive programming? Why use reactive programming? Create the sample demo application we saw in the beginning. Finally, the proof that reactive programming is non-blocking. Let's talk about what and why of reactive programming. Reactive programming is a paradigm that enables developers to create non-blocking asynchronous applications that can handle back pressure. The non-blocking part of that statement essentially means that if the client asks for, say, 100 rows of data, and the server needs 1 second to process each row of data, instead of waiting 100 seconds, the server will basically process a chunk of data, and as soon as it is done with that, will send that data to the client without blocking the client for 100 seconds. The back pressure part of that statement works in the other direction. Let's say that the server can process 100 rows in 1 second, but our client cannot handle 100 rows of data in 1 second. All it can handle is about 10 rows per second. So what the client can do is, it can apply a back pressure, basically tell the server, hey, I cannot process 100 rows of data in a second. Send me only 10 rows per second, and the server will respect that. In order for an application to be reactive, the first thing it must be able to do is to produce a stream of data. We can visualize this concept with water stream flowing through a tap. Because the data is being delivered in a stream, we have the power to slow it down or even stop it altogether on demand. Let's go to the Spring Initializer website to create our demo application that we saw in the beginning. I have already entered group and artifact on the left side. Let's start by adding dependencies. The first dependency that we need is Spring Reactive Web. So instead of using Spring Web that we would use for a classic MVC blocking architecture, we will use Spring Reactive Web. We will also use TimeLeaf. This will be used to create a front end for our application. We will also use Lombok, and we can add Spring DevTools to our application. Once we have done that, we can click on the Generate button and download our POM file. Here's how my final POM looks like. You can see that Spring Starter automatically included the starter test and reactor test dependencies. Spring Boot will also create my reactive application class, which we can use then to start our application. Let's start by creating our backend. In our backend, we will have two services, fast service and the slow service. As the name suggests, the fast service will deliver the data instantaneously and the slow service will deliver data with a delay. Here you can see my fast service class. In this class, we have a method getAccounts. This method will deliver a list of accounts. But instead of returning a list, as we would in a classic application, we will return a flux of objects. Flux is a stream representation of lists in Spring. Spring also provides Mono, which is a stream representation of an object. Let's check out our slow service class now. This class also has a method getAccounts, which will deliver flux of accounts. We use the method delayElements to simulate the slowness of this method. Each item will be delivered in the stream with a delay of 3 seconds. We also use the doOnNext method to do some logging. We will use these logs later in the video. Let's create our API class now. This class exposes a get endpoint /API/accounts, which uses the fast service and the slow service to gather the accounts and then return as flux to the client. The media type text event stream value is useful when we want to connect this API to a front end. Now we are ready to run our application, which we can do by running the reactive application class that was created by the Spring initializer. Let's call the API endpoint in our browser. We can see that the fast data was delivered instantaneously and the slow data comes with a delay of 3 seconds as expected. And that is the magic of reactive programming and streams. Finally, let's look at the proof that reactive programming is non-blocking, even on the server side. The client side being non-blocking is obvious, as the client can start working on the fast data without waiting for all the data being delivered. Remember the log we wrote in our slow service class? Here's the log printed on our server side. The name in square brackets here is the name of the thread processing the request. We can clearly see that each chunk of data is being processed by a different thread. In a classic application, the whole data will be processed by a single thread, waiting, in essence blocked, to do anything else. In reactive programming, each chunk of data is being processed by a different thread, making sure that no threads are being blocked or waiting. And that's it. Today we learned the basics of Spring Reactive Programming and built a non-blocking REST API. We also saw how reactive programming works with streams and how threads are not blocked. If you find this useful, don't forget to like, subscribe, and hit the notification bell for more awesome content. Till next time, happy coding.